Thank you very much. When I was invited to partake, I submitted an outline of my presentation, and they felt it was good. But now I've seen the group. I think I'm certainly going to learn a lot about nanotechnology, and you are going to get a short, brief course in environmental monitoring. My own career started in the high Arctic. I was fortunate enough to be involved with a project that was actually out of the U of A. And the thing that marked my life forever is the data acquisition system we were using then. It was in the days that people were first getting battery-operated systems, changing car batteries every day and the whole thing. So after 3 years of doing this and not getting a single point of data, it really became a challenge for me to get data in the field. And fortunately, it worked. So I did my master's in agricultural meteorology at Guelph and started seeing some of the applications in agriculture. And in my 32 years of being with Campbell Scientific, of course, forestry and agriculture are big players because both of these groups monitor. Now, I know this group, you're more focused in the lab still, and a lot of times, except for our recent presenter, you're out there testing a lot of equipment and using a lot of equipment. So this might be an opportunity for you to realize some of the implications of getting the equipment out in the field. And so I was merrily going along. I would have done Arctic research for a long time, but of course there was no money in those days. And so I had to look around and see, well, what could I do with my life? And I started Campbell Scientific Canada. I would say that 50% of the people we work with are simply using weather stations, and this, you'll see there's a variety of weather stations, and because there's a variety of reasons why people monitor. But we have done many various things because that was our goal, is to diversify away from environmental. And so this picture's early picture of the GCOS, what became the Suncor site at Fort McMurray. The whole watershed, the airshed system at Fort McMurray, the Buffalo region, is our equipment. And so as well, they've used our equipment for things like measuring the tension on belts and monitoring some of the large trucks. And of course, still doing geotechnical, looking at some of the dams and the stability and groundwater. So there's a variety of reasons why people measure. Of course, the oil and gas industry is also a large user of monitoring technology. In this case, this is the heavy oil extraction where they're monitoring both the steam injection into the soil, so temperatures and groundwater, and it's all radio linked. The ski areas, and certainly in Western Canada, have our equipment. And one of the things that we realize is one of the problems with our equipment is that it lasts too long. And the problem with that, and I've seen this across the board now, because I can only say there's equipment we sold 30 years ago that still works and we still support. The problem with that is we outlast now people. And people become the problem, not the equipment. And so the other big area we've been in is transportation. For a variety of reasons, people monitor. In the early days of the space shuttle, the big problem they had was the overheating of computers, so they needed an independent measurement of temperature. But prior to building the International Space Station, they did a lot of mechanical testing on some of the components they were going to do, so they used our equipment out there to measure this. And a lot of race performance, real-time monitoring of cars. And one of the more interesting projects we've had is the Confederation Bridge, because no one's built a bridge with so much moving ice. And so the big question was how much impact occurs on the bridge piers, and then also the weather of the bridge, because they have to shut down for big semi-transport trucks when the winds are too high. So my own research is up in the Arctic, up on the ice cap specifically. We have probably one of the longest collaborations with NRCan, the glaciology group. And what I like about it, it's a very good place to challenge equipment. And so if you can operate for 3 months of the year on a solar-based system when there's no darkness and it's the coldest temperatures, I think it says volumes for the quality of your equipment. Another love in my life is the measuring of fluxes. In the early years, when I started this field, energy balance of a surface was a common thing one would do in climatology and meteorology. But in the last 15 years, now that we have the sensors to measure this, especially CO2. The big push, of course, is to understand CO2 fluxes. And so this is in collaboration with Agriculture Canada and Lacombe, where we've been maintaining now for almost 10 years some constant measurements over pasture land, looking at how pasture lands fit into the whole CO2 budget. Now, there are standards. For those of you who monitor or who will send people out to monitor, there are standards that can be followed, whether it's the World Meteorological Organization, the WMO, and they set the standards internationally. Canada, we were far ahead of any other country to develop these types of guidelines for automatic stations. In part, it was due to our equipment, but in part also, the situation today is that anyone can monitor. I mean, when I started, it was financially difficult to do so, but today, anyone can monitor, but not everyone gets Environmental Monitoring 101 as an undergraduate course. And so the problem I've been facing throughout this is always to make this easier for people. Sometimes you don't even need to monitor. You could go to something like the Environment Canada website and get the data you need. And, you know, kudos to Environment Canada. They've made that process much less expensive. It used to be very expensive, but also they make it easier for you to get the data. Just a quick reminder, this is a standard weather station, and you know those are the obvious things you have is a data logger and a power supply, the various sensors. Other sensors as well, because you think, oh well, you know, these are the standard sensors we want, but it turns out for certain fields there are things you want that are not standard parameters. For example, who would have thought that leaf wetness and duration of leaf wetness is critical to plant disease work? Or for fire weather in the forestry world, they like to measure the soil moisture of duff, which is not a standard parameter. But these are things that over time you realize, oh, there's a very good link. So if we measure this parameter, we have a much better idea of our fire weather index. A camera, and I'll talk about this later, the remote communications more and more, especially with satellite technology, but also cell technology. You know, everyone wants a real-time link to their weather station or their monitoring system to get feedback and to be able to get their data back. And so we developed a camera, and if someone had told me, Claude, you're going to be manufacturing a camera, I said, you're crazy. Why would I do that? There are thousands of cameras out there. Well, there are, but it turns out there aren't a lot of cameras that work to minus 45 degrees C, but also have a whole variety of outputs and have some capabilities. And so this one is actually on Tory Building. You can get a real-time shot of the downtown in the Virva Valley. So this is what a station could look like. Basically, the important components are power supply, the data logger itself, and that's our main strength. There's a whole series of various loggers, and then various communications interfaces depending on what you're doing. The choice sometimes is, you know, people are not trained. So I want a turnkey system, and you can do that. You can do that, you know, you can set up the system so it's much easier to install. This one on the side here, everything's pre-wired, pre-programmed, plug and play, and you just go ahead and do that. My own personal is on this side. I like to wire my own things. Yes, it takes me longer, but it's less expensive, and it's much more flexible. So it depends really on the situation. Communication, as I mentioned, that's come a long way with a variety of ways of communicating, and I'll be speaking more specifically on this spread spectrum radio that we use now. The internet, of course, and historically this photograph, that photograph, how do I go back? Oh, this one probably. This photograph is interesting. It was the first radio receiver for weather satellite pictures that the U of A set up. And in those days, I remember in the 70s when I first got to U of A, they would have an old fax machine that would produce the map, and later on the TV station would come up and pick it up. How far we've come on that one. And so this might seem super simple or simplistic, but it's unbelievable the lack of experimental design that people go through when they want to monitor. And I always ask that question to a new client, why are you monitoring? Because sometimes in answering, they say things that will make you realize, well, that data is available there, or maybe you should know about this group that does this type of monitoring. So there's nothing wrong with going through a good experimental design. The where, of course, sometimes your field work will do that. The ideal field site has yet to be met. You know, there are all sorts of standards when you choose a field site, but I've never seen an ideal field site. That's probably the most difficult thing to find. What to measure? Well, sometimes that's easy because you're doing perhaps an evaluation of wind power or solar power, or you want to look at soil moisture, and those things are easy. But some of the associated parameters that I mentioned briefly, as things like leaf wetness or duff in the forestry, to be a parameter that one would normally measure. How often to measure and what kind of output in this day and age of data loggers, that's totally programmable. And then also to consider who's going to use the data. With the internet especially, I think, and then with reduced budgets that we all suffer from, I think there is more partnering and much more exchange of data. And so the onus is on the producer of the data to make sure that all the metadata are present. And so metadata, data management, data quality control, data archiving, data reports and presentations are all part of the training or the knowledge that has to come with the person who's responsible for this monitoring system. And then you get all the other realities that come in, you know, budget, spares, staff training and staff turnover. As I said, our equipment outlasts people now, and that's always been a big issue. In fact, recently I was dealing with a government agency that will remain unnamed, and their stations are just abandoned because no one's been trained to use them yet. So as a taxpayer, I really am offended by people who put up monitoring equipment and do not maintain them. It's a waste of money. And of course, all the other things that come along. And recently, it's sad to say that people now recognize solar panels. And we've seen an increase in vandalism on our panels, which in the past no one would touch. And so that brings in a new challenge. And this one I've simply repeated because I can't believe the number of people who buy a weather station or an automatic system and then spend no money on maintenance and calibration. I know there's someone from NSERC here. If you at all have anything to do with handing out money to people who monitor, if they don't have maintenance and calibration, don't let them have the money. Because it's like buying a car and not servicing it. Why would someone do that? Well, I don't know what it is. Maybe we shouldn't call them automatic weather stations. And that'll help ease that situation. But maintenance and calibration, regardless of how well the equipment works, I mean, we want the quality of data. So just a quick, some of the technologies we've developed. The snow depth sensor we actually transferred about 20 years ago from Environment Canada, and I'm pleased to say, has become a world standard according to the WMO, and that's based on ultrasound. Recently with Hydro-Québec, we've developed this snow water equivalency sensor, which will give you the amount of water in the snowpack, because especially to utility companies, but also flood forecasters, it's a very important piece of information to get. To the utility company, the amount of water out in their hills is money in the bank. And then finally, and this comes closer to your world of nanotechnology. I mean, this is certainly not small, but to us, these are very small. There's this whole development now into wireless sensors because people in some areas of crops or forestry want to be able to monitor their parameters in many environments and many of the microclimates of the crop or the forest canopy. So we've developed that. And then recently, this is our new improved camera, higher resolution. And one of the things we worked hard at doing was be able to make it such that it has no enclosure. The camera is its own enclosure. And that's starting to see a lot of popularity, because it turns out that a camera is a very useful sensor to have at a weather station, because you can tie it into sky conditions and cloud conditions. And so the other thing that's happening on the prairies more so in Saskatchewan recently, I was briefly part of that, but there's really an attempt now by various provincial agencies, British Columbia and Quebec have done this, but it's the attempt of bringing all these networks of stations together. It's quite a challenge. Federal environment have stations, the forestry people have stations, agriculture has stations, private sector has stations. And so bringing all these data together is a great idea, but it's quite a challenge. But certainly Alberta shines in that one. Alberta Agriculture and Alberta Environment have quite a good network of stations that they're maintaining properly, and we should be very proud of that. As I mentioned, BC Environment recently was the catalyst in doing that in British Columbia. And recently, Agriculture Canada, the federal people out of the Canadian National Climate Centre they have in Regina, they've been looking at applying this model to Saskatchewan to coordinate all the networks, and then hopefully we'll be passing that on to other provinces. All right, and I think that's where I'm done. Thank you. So any questions?